All right. Good morning, everyone. It's 9 o'clock sharp, so let's get going with this first session on this conference. My name is Erwin STAAL, and the next 45 minutes, 50 minutes are going to be about my experience as a DevOps engineer with various customers. How did we implement the DevOps practices there, and which tooling did we use, and how did we use it? I'm going to show you all of that in the next 50 minutes. So this is me. The monitor in front of me just failed, but I'll be fine. This is me. My name is Erwin STAAL. I'm from the Netherlands. I live in a beautiful town called Assen, which is up there, which is famous for absolutely nothing. You might, however, have heard of us because the Formula 1 Grand Prix next year is going to be in the Netherlands. But we just lost that to Zandvoort. So no, that's not going to be in Assen as well. So I'm a DevOps engineer and a software engineer. I combine the two most of the time. Thanks. And I work for a company called 4.net. And we do training and consultancy, mostly on the .NET, the Microsoft stack, as you probably would have guessed by such a name. All right, so via 4.net, I've been working for KPN in the Netherlands, in Groningen. And KPN is one of the largest Dutch telecom operators we have. I think it's even the largest. And for them, I've been building on this product called KPN Hotspots. And this is the portal of KPN Hotspots. And it's a product which allows our customers to use Wi-Fi on public locations. So that could be either a restaurant or a hotel or train stations, stuff like that. There's 4,500 locations in 4 European countries that use this product. And the product itself isn't new. It's been around for a decade. But the current implementation 3 years ago had been written in PHP. I'm not sure if I'm even allowed to say PHP here. Guess I can, right? But it was not maintainable anymore. So we had to rebuild the architecture, rebuild the application to be able to innovate on it again. And so we chose the Microsoft stack to do that. It's written in .NET. Most of the stuff is written in the old framework, not .NET Core, since that was just in version 1.0 in those days. And 1.0 was kind of, just not finished. So we chose to do it in the old framework. But it worked out pretty well eventually. And the assignment we got wasn't just about building the application from scratch and make sure that it would be maintainable this time and we could innovate on it. It was also about setting an example within the organization on how to do DevOps and on how to do continuous delivery. KPN is pretty large. It's 15,000 people working there. That's an enterprise level. So you can imagine what that means in terms of doing DevOps in such an organization. So it was a pretty small project, which so also had to be an example for how you could be doing DevOps in such an organization. That's there as well. So to show you a bit of an example to how far we've gotten with that, let me tell you a little story. And the story starts in August last year, which is in the middle of the holiday. And I got a call from one of my colleagues in Amsterdam. He is on the more of the infrastructure network side of things, whereas I am on the software side. And he called me and said that one of the largest customers we have gave him a call telling him that one of the features had gone missing in their portal. One of the payment methods out there had gone missing. Normally, there's the ability to go online for free with some limitations for the user or pay by credit card, stuff like that. So one of those methods had gone missing. And while he was explaining to me what he was missing, it came to my mind that this could perfectly be related to a change I had made the day before, and which also had gone into production the day before. So I hang up the phone, and with a colleague of mine, we got into our logging system. We used Kibana for that. And quickly, in a minute of 5 to 10 minutes, we found out that indeed it had been the change I made yesterday that caused this error in the portal. So we had proven that I had made a mistake. We wrote a test to prove I had made a mistake. We fixed the error I had made the day before and got it into production in just over a little over an hour. And that was a moment that I, as a DevOps consultant, DevOps engineer, got pretty excited about what we had been able to do just there. We didn't need workarounds or whatever to get this change, this fix into production. No, we could just use our regular release process we had been using hundreds of times before to get our stuff into production. Yes, I should have written that test the day before. That's right. But I didn't. I forgot. It just glipped through all of the checks we have. It ended up in production, but at least we were able to very quickly fix that. One of the main reasons I believe I was able to do that, I was able to fix this so quickly. And the business also was really excited about that, as you could probably imagine. They had never seen that before in such an enterprise. So that was really, really great. One of the main reasons why I was able to do this is the fact that I had made that change just the day before. And not, as you see more regularly, a month before or weeks or whatever. So if you would ask me what I had for dinner 2 days ago, that's going to be quite a challenge for me to remember, let alone you're going to ask me about a change I made 4 weeks ago. That's going to be troublesome for me. So the fact that we were able to do this so quickly was mainly about the fact that I could remember the fact that I'd been changing this yesterday and it was still on the top of my mind. All right, so all of we had been doing so far was about bringing the value we have to our end users and doing that in a quickly and sustainable way. And I was really proud at that moment on the fact that we were able to do that. So the definition for DevOps I always like to use is this one of Donovan Brown. And he says DevOps is the union of people, process, and products to enable continuous delivery of value to our end users. So the last bit there is pretty important. It's about bringing value to your end users, not bringing value to your test environment or to your QA environment. No, it's about bringing value to your end user. That might be a web application, that might be the mobile phone of the end user. That's the only place where we actually make money out of the stuff we do. So we want to get it there as quickly, as safe as we possibly can. So the rest of this talk will be about how did we implement the process at KPN and how did I do a few things in other companies. Within KPN I had to work with on-prem data centers, so virtual machines, etc. But you can obviously do even more advanced and awesome stuff in the cloud. So we're going to have a look at both in terms of practices and in terms of tooling. So before I dive into a few demos, I want to quickly talk about the branching strategy we used within the KPN, which I think made a huge difference to the way we were able to work there. So what you see more often is a branching strategy like the one you see here. There's a lot of variation on it, of course, but what you see here is that there's a master branch and a development branch has been created of this master branch, and every time someone starts to work on a new feature, he creates another branch and work there. Work on the branch for probably weeks or months. I've seen people doing that, and that's okay-ish. But then when someone else starts to work on another feature, they create another branch. And so the moment that feature A is done, after a few weeks, and it's being merged back to this development branch, that's okay, that will probably work out fine. But the problems start when team B starts to merge feature B back into the same development branch. At that point, you're quite likely to get a lot of merge conflicts because the change has been so big. You have touched so many files that also the people in team A have been touching. So a lot of merge conflicts will probably arise, and you will probably need a day or two to fix them. a lot of unit tests might fail because you've been interfering with each other. So you might need, as I said, days to fix it. I've even seen companies add sprints to fix this stuff, to make their development bench, to make their master bench able to go to production again. Stabilization sprints, they were called. So we chose to do things differently. We chose to go through this trunk-based development approach. And yes, we still make feature branches. So and on those feature branches, we do our work, and then we merge that work directly back into our master branch. The main difference here compared to the previous one is that we will work on such a feature branch only for a day at most, and preferably even shorter than that. So those changes go into that master branch at least once a day. So the chances of having a conflict there is pretty small, since the chance of you having worked in the same file as your colleague is not as big, because it's a very small change. And if there is a conflict, then it's probably going to be an easy fix with just a quick chat with your colleague, since you've been just doing it and it probably just go about a few files. So the other benefit of this is that as a developer, you get very fast feedback on the change you've made, and you get very fast feedback on how that change integrates with the changes your colleagues have been made, and does that still integrate? Does your application still build? Do all of your tests still run? Stuff like that. There is, however, also a problem with the approach, in the sense that developers need to be aware of the fact that the stuff they merge into the master branch could be in production in 30 minutes. So there's no phase anymore in which they can stabilize their stuff, can fix their stuff. No, it must be done, finished, tested, etc. when it goes into that master branch. And we need to put stuff in place to protect errors from getting into the master branch and getting into production. So the rest of the talk I will explain you how we actually did that. So time for a few demos. All right, so the process starts with a pull request, which is simply the question to a colleague of yours to review your code and see if you made any errors in your change. So this is what that looks like in Azure DevOps, the product we used back then. And there's a few things around here I want to show you. So first of all, here on the right, we have policies which are required before you are allowed to merge this change into the master branch. So for example, you see that none of the one required reviewers has approved my change. So there in the right bottom, you see that Bob, the reviewer, had been requested to review my code. He hadn't done that yet, so he first has to review my code before I can merge this into master. You also see that a build has completed. So while doing this pull request, on the background a build has run, my code has been compiled, and all of the unit tests I have, which is a pretty comprehensive set, it's giving a good feedback on the change I made. It has run, and it says it succeeded, so I'm allowed to merge from that perspective. So that's a few built-in things here you can easily just enable and do very quickly. You can also integrate third-party solutions, and that's what I did here. I made a connection with Sonar Cloud. Sonar Cloud is a tool that does a static analysis of your code, and it can find duplications, it can find vulnerabilities like the one you see right here. It also gives you a metric on the number of tests you have, stuff like that. So what I try to do here is implement an MD5 crypto service provider, which in 2019 is not the best way to hash a password. So Sonar Cloud nicely told me about that and told me that I probably don't want to do this if this is about hashing a password. So there's a few links in here that you can click, and it will tell you better alternatives, stuff like that. So this is all built-in rules of Sonar Cloud. You can also add your own if you ever wanted to do that. So this is what Sonar Cloud, the dashboard of Sonar Cloud looks like. And what you see here is that there are various metrics on number of bugs in my application. There's 3 vulnerabilities in this application, although it's very small. It's just a demo application. There's 1 hour of technical debt that I have to fix. And the code coverage in this application is as low as 3%, which is not very good, right? We all do unit testing these days, so I should be doing better here. So, and you could then easily click any further into the issues it has found for you. And that could be also a lot of things. For example, I yesterday uploaded an image and I missed the alternative tag, so it will tell you about that. It will tell you that there's a few methods in there that aren't used anymore. There's also one in here about the fact that I have a nested if that should not be nested. I should make my constructor protected or static, whatever, stuff like that. So there's also the things here that can tell you something about how your code is doing. And the most important thing is that it already does that during your pull request. So it's very early feedback on your work as a developer on how you are actually doing here. So there's a few built-in things here. You can use third-party stuff to do other checks. And if you even want to do more and there's no direct connection between it, you can always use webhooks to do alternative things. So what I did, for example, as you can see right here, it says that the PR title is incorrect. That's because I'm requiring that all of the titles I have start with this brackets and then some sort of code. And that's just a simple check on the title of the PR. It doesn't really mean anything here, but just to show you that you can do this. And you now see that I just fulfilled this requirement and it's ready for a review. And what's happening here on the background is there's a webhook being fired to an Azure function. That function is doing some checks on the pull request I've made, and it sends back that it's okay now. So there's various ways of how you can implement checks already here in the pull request, even before you get stuff into your master branch. All right, so now that we finished this pull request and merged it into master, it's time to get this change into production. And for that, we obviously need a pipeline. So I've created a nice test pipeline, which I will show to you. So here on the left is the artifact. It's the result of the build, which comes into the pipeline. And then there's various environments through which my change will go up until production right here on the left. So let's start with what's happening here in the testing phase. There's quite a few things going on here. And one of the interesting things here is that while I'm doing this release, while I'm releasing my application, which is the deploy Azure app service on the bottom, that's the easiest part here. While I'm doing my release, I'm also creating the infrastructure in Azure I need to run my application. And that's these 2 steps over here. So if my infrastructure does not exist, if my database isn't there yet, I create it here on the fly. If I need to do a change to that infrastructure, that's happening here on the fly during the release. And the same goes for the deployment of the Azure web app I'm using to deploy my application too. And in this particular demo, I'm doing that using the application resource manager templates. And that's a solution which is only for Azure. It's a JSON style of declaring your infrastructure, stating what your infrastructure should look like. So, for example, this bit over here, this resource over here, states that I want to have a SQL server, and that this is your login name and this is your password. So this will create me a SQL server in the Azure cloud. And then I obviously also need a database. So this resource over here will create this SQL database on this SQL server for me. And you see stuff in here like the addition, and the addition says something about the amount of compute I get from the Azure platform. And there's also the max size, obviously, so how big can the database become. So that's all in here. And if I wanted to make a change to either the size or the amount of performance I get from the platform, this is the place to do that. You don't go into the portal anymore and get the slider to the right to get more performance. No, you make a change to your infrastructure right here, and deploy that towards Azure using your deployment pipelines. So that also means that this is our state. If someone does go up to the portal, make a change, and you then run these templates, that change will be undone by the value that's in these templates. But that's a good thing, because these templates, just like your code, also go through this whole pull request process I just showed you. So you can't get a change also for the infrastructure side of things into Azure without having that reviewed and without having it gone through a pull request. All right, so this stuff will create my infrastructure, databases, web apps, even certificates, stuff like that. It's all being done right here from the ARM template. If you want to know more about them, then today at 12:20, right after lunch, my colleague, former colleague and friend Henry Bain will talk about the ARM templates for 15 minutes. So if you want a bit more detail on how to work with them, then you might want to go to his session on this topic. All right, so now we have our infrastructure in place. We have a database. We obviously also want to run migrations on the database. We need to make changes to the database. That's also something I'm doing right here in the release pipeline. And I'm going to show you how I do that. This is the demo application I'm going to show you today, which I made for this purpose. And I made a database menu item over there. So what we did at KPN and what I've been doing at multiple customers is used Entity Framework to handle our database in code. So this fruit class over here represents a database table in my database. And this is what that looks like in code. So it's no SQL statements over there, it's just regular C#, simple C# classes code that represent my database. If I don't want to make a change to the table, I'll just add a property to this class like I did here. I added a stock property. And then by running a command on the command line, Entity Framework will create a migration class for me, which is the one on the bottom here. So I didn't write that myself, that was generated. And what you see here is that if I want to migrate up my database, it's going to add this column, which is an integer, etc., etc. You could also migrate down again if you ever have to go back. So this is all generated for me. This just goes into source control, like any other thing. Just like the ARM template, just like your code, just like your test. And they also just go through your PR stuff, your pull request, like the other stuff we already mentioned. So at KPN, I already told you we were running our application on on-prem hardware. We were using virtual machines back there. Weren't allowed to go to the cloud back in the days. And so that meant that if we wanted to do a release, we did that using a rolling deployment. That means that we were having multiple virtual machines, and we would get one of the virtual machines, we would pull it out of the load balancer, update the version of our application on that machine, test it a little bit, and put it back in the load balancer, pick the next virtual machine, update that one, and put it back in the load balancer. That does mean, however, that at that moment in time, while you are releasing your application, there's multiple versions of your application running against the same database. Against the database I just migrated a few seconds before updating my application. So that means that if you go for this approach, you need to make sure that your database is always backwards compatible. That can be hard sometimes, because, for example, if you want to change a column in your database, you probably need multiple versions of that change. You can't just change the name of a column, since there might be two versions of your application running against it, and that goes wrong. So it comes with the cost of doing stuff like this, but it does enable you to deploy your application to production whenever you want, multiple times a day, even on Friday on 4 o'clock. Doesn't matter anymore. So I think that's a huge win over there. And yeah, it comes with the cost of having to be backwards compatible with this stuff. All right, so now that our application has landed on our test environment, we need to run some additional tests against that environment. So in the pull request, we already have run our unit test, but unit tests aren't enough to cover all the needs we have. So before I go into how we did that at KPN, let's first have a look at this testing pyramid. Martin Fowler wrote, as one of the many, a blog on this testing pyramid. And what it basically says is that the type of test in the bottom, which are the unit tests, those are easy to write. Those are most of the time easy to maintain, and they are very fast to run. So we want to have a lot of them. We want to test as much as we can in our applications using unit tests because of the stuff I just mentioned. But unit tests can't cover everything. There's various examples out there of stuff that had been unit tested, but it wasn't a UI test, so stuff still didn't work. So you need more than just your unit test. So at KPN, we both have the service test going against our API, going across borders in applications. And we also have the UI tests for stuff that we can't do with unit tests. And we chose to use SpecFlow to do that. And SpecFlow is the .NET version of Cucumber, which is the Java thing. And it's a natural language which allows you to describe the features in your application and describe your test scenarios. And this is what that looks like. This is a very easy example of what such a script, such a scenario could look like. And this is really nice because our tester we had at KPN, he was pretty technical, but he wasn't able to actually write the tests. He couldn't write code. But we could discuss scenarios like this. So this was a very easy method to get in place what we needed to test. And we also could discuss these scenarios with our stakeholders. They even became part of the documentation we have. They describe our product. They describe what it needs to be able to do in terms of features. So this is what that looks like. And then you obviously need some code to get stuff running. And this will then be generated into methods like the one you see here. This given as an authenticated user is the exact same one as you see over here. So this line over here was generated into this function. And right here we use Selenium to control our browser. So when we run these tests, a browser will start, Firefox or Chrome or whatever, and this test will actually start clicking around in your browser. It will try to find buttons and input fields and add values to those input fields, click a few buttons, and then in the end, on the bottom, it will try to do a few assertions on if the stuff on the page is actually what you expect to be on that page. So this is pretty cool, pretty readable. All of those statements are reusable. So if you have another test that also needs an authenticated user, that function is just automatically being reused. But as I said, it does come with a cost. You need some machine that can actually run a browser. You need to actually run a browser, which is much, much slower than a unit test, for example. Also, maintaining these tests is much harder than a unit test. You, for example, always need some data in some database or some data in a third-party application, so you might want to add stubs or doubles there. So they're harder to do, but I think you need them to be able to deploy your application into production in a very reliable way. All right, so back to the release here. Now that my UI tests have run, it's time to deploy my application to my production environment. And I'll do that using a canary release approach. And I'm going to explain to you what that means. So on the left here, you see my staging environment, which is an identical copy of the infrastructure, at least for the web app, of my production environment. And what I do is I deploy the new version of my application to this staging environment, but no one gets to go there yet. So it's just living there. I can do a few tests to see if it's up and running, but there's no traffic going there yet. So the next step here is to actually send some production traffic to this environment. So after this stage has been done, 10% of my production traffic will go to this staging slot. So 10% goes to this new version, 90% of the production traffic still goes to the production environment. And then, before this change is allowed to go further, before I'm going to send 40% of my traffic to this environment, I'm using the Azure Monitor release gates here in this deployment. And what this does is it will monitor my alerts in Azure. For example, there's one that looks out after my CPU usage. There's one that monitors the amount of errors I have in the application. And if neither of them goes up, then all is still okay, and this release is allowed to go to the next stage. But if, for example, my CPU usage would go up with like 20% or something, it will be seen here, and I wouldn't be allowed to put this change any further into production. So the current state of this release is that there's now 40% of this traffic going to the staging environment, and 60% is still going to my production environment. So this is what that actually looks like on the dashboard I have in Application Insights. And as you can see, especially when I move my mouse off it, you see that there's indeed in the last 4 hours been 6,000 requests to the production slot, and there's 4,000 of them going to the staging slot, which has the new version of my application. I'm using a PowerShell Azure function to generate some traffic. That PowerShell Azure function stuff just went general available a few weeks ago, so I had to use that, obviously. Right, so how do they do this? Well, they use cookies to actually do this. So what you see over here is that, let's zoom in. There's a cookie over here, XMS routing name, which is currently set to self. That self means it's going to the production environment. But probably if I would remove that cookie and would refresh a few times, it might change to staging, and I would go to the other environment. So I can actually change that. As you see, I'm currently on the version of the 4th of November. So if I change this one to staging and reload my page, it will actually go to the version of yesterday, which is currently running on that staging environment. So the load balancer there automatically picks users and sends them to either one of them based on these percentages. But you can also do it yourself if you want to. And you can even do that using a query string in the browser. Like this. So you could even have a customer, give a button to a customer, for example, to have him being forced to go to this new version of your application if you wanted to. All right, so this is pretty cool. It allows us to nicely move this new version of our application to our production environment and monitor what that does. I, for example, have been in a situation where after only sending 10% of the traffic to this new version, our CPU usage went up with 50%, with only 10% of the traffic. So if we would have done that just one by one with all of the traffic, we would have been in trouble. So it actually saved me at least once. But although it's a very cool technique, it's still a bit of an all or nothing thing. It's still all of my users see all of the new features I might be releasing to production, and you might not want that. You might be more specific in that. So for that exact purpose, we also have something called feature flags. And feature flags are basically just if statements in your code that allow you to switch on or off a piece of new functionality. So for example, this is what that could look like. This is an ASP MVC application, and the 2 lines over here, they call a feature flag API to request if a certain feature flag has been enabled for a particular user, and there's a true or false being returned here. And in the actual view, I'm using that value to show a new div to a user. So this allows me to just show this particular div to just this particular user, which is pretty cool. And this is just a div, so it might not be that big of a deal, but this might actually be hiding a completely new feature for most of your users. So what this basically allows you to do is separate your deployment from an actual release. So you could go into production 10 times a day without actually releasing any new feature to your customer. So you could be doing performance improvements, for example, on the one end, going to production but not releasing the new stuff that was also in the master branch at the same time. So it allows you to do a separation of the two. That makes releasing your new features a business decision instead of an IT one. So IT can just go on and move its changes and stuff into production. Oh, there's always this one application that does go over your things, right? It's Microsoft, by the way. On an Apple, yep. All right, so this basically makes it a business decision, which is great because I, for example, have been in the situation where we would have periods in time in the year where our organization, our business, didn't want to release new features because they were busy enough with handling just the regular process. So, but this enabled us as the IT department to just go on and ship features and get feedback on most of the things we changed, but not enable new things that might be too much for the rest of the organization, for the one on the help desk, for example. So that's really cool. What really makes them interesting is when you start to combine them with groups. So not with just individual users, but it also allows you to create groups of users. For example, you might have a group of users which you know very well, and which you want always to test your new features first before you actually release that new feature into production. Or for example, someone or multiple of your customers reported a bug. You might then want to make a group of the people who reported your bug and have them test the fix first using a feature flag before you just release that fix into production to everyone. That allows you to get feedback from them first and make changes if you need to before getting this change into production for all of them. So this also means that we don't do rollbacks anymore. I've been there in the middle of the night having to do a rollback. You don't have to do that anymore if you use feature flags, because if something goes wrong, you simply turn it off. And you will be back in the state where you were before. So that's pretty cool. All right, are we doing on time? Great. All right, so one more thing I want to show you here in the Azure portal, which I think is a really great feature to monitor your applications, because also we obviously need monitoring and be able to quickly identify when things go wrong. And this is the application map with an application insights that shows the my current demo system. So on the left there's some testing stuff that runs some requests against my environment. You see there both the production and the staging environments getting various calls. And you also see the feature flag application I just showed you in code. And you obviously also want to see that in action, right? So I forgot to show you that. It actually works. You saw in the code that in the home control over here, it gets the user ID. That user ID is being sent to this feature flag API, and it will then go back with true or false. So I'm faking that with the just something on the quiz thing, and yes, there's my new awesome new feature div. So it actually works. So this application map, going back to shows you the current state of your application. And it finds these relations sort of by itself. I didn't tell it that, I didn't tell the application map that I have these applications and I have the databases you see here. It figured that out by the logging that's in there and by the fact that it's running in Azure and it's correlating the requests with each other, stuff like that. So there's no additional setup to be able to do this than just enabling application insights on the various applications. Those applications don't even go to the same application insight instance. There are separate ones for each application, and it still works. So that's pretty awesome. You also see that there's a few errors here. Quite a lot of the requests actually went wrong. That's because this morning I deleted my database, my feature flag database. So obviously that could not be found anymore. But you can now see that here right away. And you can now easily see that since there's alarms going off over here, what caused this error is the fact that there's something going wrong over here. And you can then just click on the links and it will show you the errors that are in there, and you can actually click on them to see what happened. And you then get quite a lot of detail on the actual error that occurred. It's not always that fast as you see. There we are. So it's been a dependency failure, and it will show you with quite some detail on why this actually went wrong. And this error is pretty obvious since I just deleted my database. So it could not be found anymore. And there's also this view over here, which then nicely shows you the breakdown of application, the breakdown of calls between the applications from the actual web application to the database. And it shows you how long a particular call took. And it also shows you where the exception then actually appeared. So a pretty awesome way to find the errors in your system. At KPN, we didn't have application insights since we weren't allowed to go to the cloud. But what we did there is that we added an HTTP header in each call that was made between systems. So a log identifier was passed on in the header between applications. And applications would reuse that log identifier with all the logging they would do. So we could also do in Kibana what you actually can do over here by just picking a log identifier and requesting all the logs that were from that particular log identifier. That would then show us all the logging there was throughout various of our applications. And we could also then do stuff like this in terms of timing, etc. But obviously we had to do a bit more work than what you get here just out of the box. But you can do it on-prem as well, right? All right, let me check. That was the last thing I wanted to actually show you in Azure. Let's go back to the slides for one moment. So you might actually be wondering, in a talk about modern development practices and DevOps, etc., it's 2019. Shouldn't we be talking about moving from monoliths to microservices, and shouldn't we also be talking about Docker and Kubernetes? Well, the fact is, the truth is actually that I think microservices and also Kubernetes are pretty hard to do. It's pretty hard to get right. I've been there a few times, and it's pretty hard to do, and that's why I think, and I found a nice blog of Martin Fowler on this particular subject, is that you probably always want to start with creating a monolith. You actually never want to start with creating a microservice. And Martin Fowler explains that with this graph. What he says is that you will be much more productive when you start your new adventures with a monolith compared to doing that with a microservice architecture. You will be much more productive simply because of the complexity of this microservice architecture and getting that right. So there might actually be a moment in time in which you see that the monolith you've built becomes too complex and you might want to split that up into multiple smaller microservices. But let's be honest, we not all are the Amazons or the other large enterprise in the world, and most of us don't actually need a microservice architecture. Yes, it's cool, but I think it's about bringing this value to the end user, and we can also do that with a monolithic architecture pretty well. The same goes for Kubernetes. I've been building a multi-data center Kubernetes cluster, and that was lots of fun. I have to admit that, but it also was pretty hard to do. You then quickly figure out it's not that mature as I thought when I was starting this adventure. It also did cost a lot of money. So also on that perspective, I would advise to go probably with your, at least in the beginning, with your monolithic application to, if you can, this platform as a service offering in the cloud, which is much, much more easier than probably going for this Kubernetes approach, which is pretty hard, I think. So it should be all about bringing this value to the end user. And I think that keeping it simple is really key in there. In terms of DevOps and in terms of continuous delivery, it doesn't really matter. I've been doing it in an enterprise with virtual machines. Yes, I would have rather done it in the cloud, etc., but I had to do it with virtual machines. You can even do it on virtual machines, right? You don't need the fancy stuff out there. Just go for it when you actually need it. You don't need it to do proper DevOps or do proper continuous delivery. So with that, I want to conclude my presentation. Are there any questions? Ooh. Well, that's a good point. No, I can't finish a feature in one day. That's not going to happen. We still have features that I've been working on for 2 months. But I was able to split up that work in such a small batches that I was able to do that in such small increments instead of creating a feature bench on which I was working 2 months. So yeah, most of the time I was able to make these small changes, these small increments. But not always, I have to be honest there. Especially if you do the more architectural stuff, change the implementation which goes through all of your stuff. If that happens, you probably did it wrong in the first place, by the way. But so that may take a bit longer, but the normal features and stuff, yeah, that's pretty good doable in this way. True. Yeah, so a feature flag could just be as simple as not showing a menu item, right? Just not showing a button on a page, or while you are developing, enabling it and just disable it while you go to production and have the old code work instead of the new, stuff like that. I haven't had any problems with that. Also with more complex stuff like doing indexes or whatever. Yeah. That just works perfectly fine. I have to admit that I mean, it generates this migration for you, and you then always have the ability to change it a bit if you want to. So I've been adding a few ones which didn't quite work out. So what you can do in such a migration is then just add some SQL to actually do what you want it to do. So then it's not the generated version anymore, but at least it's a migration which is in code, which goes through your pull request, etc. So most of the time it's okay, but you have the ability to do your own stuff if you need to. Good question. This is one I've been writing myself, because I wanted to do that sometime. And well, okay. But there's products out there that just do what I showed you here. Launch Darkly is one of the most known ones, and I've been setting up some demo projects with them, and it looked absolutely fine. You have to pay for it, obviously, but I mean, writing some code is also going to cost you money. So yeah. So I would go for Launch Darkly first. All right. There's just a few seconds left. I think I have time for one question. Is there any other question? All right. I will be around the next 2 days. So please come up if you have anything. And have a great conference from here. Thank you.